we talking about?
Let me get back to it.
It started, just so you know.
Oh, okay. So what the group activity says is, for this week's group activity, come up with a series of experiments you would like to conduct on limited budget and time to test the theory of plate tectonics.
Unlimited budget and time.
Yeah.
Oh, so this is just like what would we like to do if we could?
Mm-hmm.
Oh.
So, what would we like to do?
That's a good question. I would like to do. I mean, I'd like to be able to dig in rocks and then like check the, um, like the different fossils from different countries and like compare. That would be so fun. Like, I mean, digging up fossils probably wouldn't be that fun. Once you find them and you can compare them, be like, hey, these two creatures like lived on this same place. Like these places had to be connected at one point.
Oh, and you could see how long it took for them to get to where they were.
Yeah, like you could, and then you could like, you know how they test the age of the rocks on like under the ocean surface, like for like how long. So, but the thing is like you can only test up to like 180 million years for the oceans.
Yeah, so that's why you have to test the fossils in the ocean, because they can only test so far.
Yeah, like they'll only be like 180 years old. So like and everything out of the ocean is kind of just like it shows you. I think the only thing that's beneficial about like the ocean is like you can see how long like the age is and kind of just see because if you did after you do the first lab you'll see that like there's like little time zones like one's like 10 million years, 20 million years, 30 million years. It goes up to 180, and then like the longer they are, the faster the plates are splitting, and then like the smaller they are, the slower. And so like that's one way to test it. But the thing is like landmass has like older like continents and things have older like rocks because the what's the it's not the mantle.
Yeah, the mantle's coming out of it. Exactly.
I think that's what it is, or it's like a lithosphere or something like that. But I'm bad with names. But the crust of the Earth, like the top, is under the ocean is only 180. The oldest piece they found is 180 years old because it's continuously going underneath the continents and then just like melting. It's like in the ocean, it's like creating and then melting. So like the way to test that is, I mean, I guess it's a way to test whether plate tectonics is real. That'd be another way to test it. Just like go into the ocean and test each piece and kind of see how fast they're moving, how old it is, and then kind of like show how things are moving closer. And because like I think there's a plate between Africa and the United States, and that one's pushing like out, so that it's pushing against the United States like westward, and they're pushing against Africa eastward. And then there's another one. Yes, because it's a ridge. It's a ridge that has like a ridge between those two countries. Yeah, I was right. Except for it's a little different than I thought. But yeah, essentially. And then there's a couple ridges. Interesting. Yeah. So we're just mainly supposed to discuss what we would do if we had. Well, I would definitely do that. I would really love to test like all the ages of the rocks, and I wonder if they use carbon dating. That's a good. I'm gonna look this up. What do they use to test?
Well, I wonder if we could bring back the ocean drilling because it looked like they stopped that in the 80s.
So what is ocean drilling?
Where like they would go kind of close to the mantle and they would drill right there and then test how old it was. The thing is that they can only go back so far, so they had to start testing, I think, the fossils. I wonder if there's like some way that they can advance it into that.
Yeah, well, the problem with it is literally because the ocean crust is being destroyed. Like it's being pushed under. Cause like the way it works is like so you have a continent, continental plain or whatever it's called, and then you have the ocean's crust being pushed underneath the continent and just melting.
Yeah.
And so like it's just continuously going like out of the like where the ridge is being pushed out and then pushed under the continent because the continent is like thick and dense and then or no maybe it's not dense and then like the crust is dense, the crust is pushing under it like foam would push under like a sheet of iron would push under foam. I think that's how they described it. I think that's what I remember.
Like I'm saying they would test like out in the ocean. Like, are you saying that they can't do that because it's fishing?
Yeah, like all the fossils and like everything are just gone. It's just like so like the best way to test like the ages is just on the continents themselves because that's where the older bits are. Like so like yeah, the oldest bits they're gonna find on the continents because the ocean is just like 180 years old. Like it's creating new, not really new, but reusing whatever it was shoved under before. But it's recreating itself. Like it's melting and then creating and melting.
Okay, yeah, that makes sense. So I'm wondering with the movement though, if we would have like GPSs pretty much on every fault line on everything, and then it takes for the plate tectonics to move, we have like the video of them like slowly moving.
That would take forever because like it's like 10 million years. Like
yeah, that's true. I mean, like even in like a span of 10 years, there's something kind of moving, and if we could at least show how it's doing it,
I guess that's true.
But
we could. So we could like I don't think are we supposed to only talk about one?
I think it said experiments.
So let's see. Oh, this is just the Google Hangouts bit. Look. So.
Oh, my thing just said couldn't start the video call because of a network error. Is yours still going though?
Mine's still going, but like mine just says that you don't have video.
Oh, okay. So it's still hearing us.
I mean, it can hear you on my end at least.
Okay. So we'll be fine.
Yeah, like maybe I can try calling you again just to try and add you. Here, I can do it because I remember your email. But yeah, my mic probably picked you up too.
I'm trying again. We'll see if this works.
I see you, but I don't see a video.
Oh, is it on?
It says, presenting you to everyone. Oh, I didn't want to do that. Whoops.
Wait, what did you?
I presented you to everyone. Stop presenting. Okay, you're still here though.
Okay, sounds good. Because I'm just like, I don't know what's happening.
Why are you? Okay. So it says we're to meet as a group and we'll sometime applications and to facilitate collaborative work. Okay. You need to meet once a week. You can access for this group activity come with a series. Oh, series of things. So how are we supposed to? Okay, so we just submit.
So we're submitting the video link, but I think we're also supposed to just type up notes at the end and kind of talk about what we talked about, and we just submit the same thing.
I'm starting the quiz just to look at what it is, because I want to know. I want to understand this fully.
Yeah.
So yeah, there's 3 questions. There's submit the link to your group's recording and your group's write-up. Okay. Well, there's only 3 of us, or 2 of us, so. Which is kind of good, because usually in groups of bigger than 2, I feel like there's always someone who doesn't do anything.
Yeah.
Okay, so we need to submit our link and our write-up. Okay, so I'll start writing this up. We want to, an experiment we would like to enjoy to do. An experiment we'd like. Interesting.
So we wanted to try and find fossils and see if we can compare them to see if they were in the same place. Is that what you're saying?
Yeah, like
to test that movement to see how long it's taking that get.
Because there's a dinosaur. It's like a mosasaur. No, it's a mesosaur. Mosasaur's huge. So it's a mesosaur, and it's in like South America and then Africa.
Okay.
And so it's a really small creature. It's not like a big creature. It couldn't travel long distances. At least that's what it said in the reading. And so like somebody used that as a basis to show that the countries at one point had to be linked, because it's a like 2 different countries aren't gonna have the same exact animal. Like we don't have tigers, so.
How do we get tiger fossils if we have?
Yeah, like how do we get mesosaur fossils if they have mesosaur fossils? So like they tested that, and so that was one way to show. And then another, I don't know if this actually shows that they were connected, because there are certain areas that had like lush rainforests in like the prehistoric age, and then there's some that had like ice. So they think that like the continents when they were formed together were like placed more southern, kind of like just like a little bit.
Mm-hmm.
So like there was part of it that was just completely south, and there was part of it that was kind of more near the hemisphere. That line that for like the tropical area, but
yeah, I get
so and like apparently there's like really big like coal fields there, and like it's really lush. That's like to show, yeah. But that's like the way he described it. He said like there was the whole world wasn't just like an ice, but I don't think that has to do with plate tectonics. So we'll look for that.
I think that's kind of what you were talking about with the geography of fossils.
Yeah. Did you find an article about it?
Yeah, I'm trying to see what it's about.
Okay.
It looks like they tracked the animals back to 540 million years ago, so they can track that a lot more than the Earth. And they have an animation of movement of continents over the last 750 million years. I don't know if that's what we're looking for. Is that?
I just have to check this Google Hangouts to make sure it's still running. I wish it told you how long you've been live for. I'm gonna be so sad if we lose all of this because we did it wrong.
I don't think we are though, because it still says live on.
Yeah.
Live on my side too.
Oh, so it doesn't even say you're in here, but I mean, we'll be able to hear you, so it's all good.
My little invisible words. Okay.
And then, okay, so we thought about experiments of comparing fossils from other countries to kind of show that at one point they had to be linked. And then we've thought of using the ocean floor to show that like it's creating new crust and pushing out. And then what's another way they've done it?
I think GPS, the GPS one, because
tracking.
yeah, because they check the fault lines to see if the fault lines are moving, like the whole thing about California is going to be in Alaska soon,
yeah,
and everything doing with the fault line.
Okay, so we thought about GPS tracking the fault lines over a large period, like over a period of years.
Yeah.
Geology is a lot more interesting than I thought, but so far I think volcanoes are boring.
Volcanoes are boring?
Like, because I wrote my bibliography on the volcanoes.
Oh, okay.
Or not bibliography, bibliography. Yeah, I started that one, and finding those articles was hard. Oh my gosh.
It is hard, yeah.
Like, finding them that you understand, like, there's these words. Okay.
I was like, hopefully I'm saying this right.
Google this word. What does this mean?
Okay, so how does fossils influence continental drift? It has two answers on here.
Okay.
It says, let me start with the continental drift. The continental drift, it's the movement of continents on their surface, so that's very self-explanatory.
Yeah.
And it says that the way they move depends on the plate tectonics that they're next to. So it's going to be the divergent, convergent, or transferring plates. So I mean, by looking at the continental drifts, we can tell what kind of movement it's doing.
Yeah.
So like California is, the San Andreas Fault, so that's more of a trend. Yeah. That's drifting away from the United States. So that's divergent, right? So that's the trajectory.
Divergent is when they're both moving away from each other.
But it's not convergence when they go onto like that, isn't it?
Yeah, together.
So then is it the transform?
I don't know that one. I have to look that up again because that one was a little confusing.
Because it says or drift. but I don't know if we have to drift.
So transformative, that's another one?
Transform.
Transform, what's it called? Like transform.
Just transform plate. So there's like divergent or convergent transform.
A transform plate is a boundary also known as a conservative plate boundary, since its faults neither create nor destroy lithospheres. It is a type of fault whose motion is predominantly horizontal and either sinistrial, left, lateral, or inertial. So they're kind of just like moving like this.
Oh, so that's the fault line part, right?
Yeah, so like say that they're moving like this against each other. That's that. So there's this one. There's this one, and then there's this one.
So I think that's the California one because it's moving away from us, but it's not. So the continents will drift whether or not there are fossils. So we can say that the fossils will not influence continental drift, but we can use fossils to track how continents have moved.
Okay, so
the continents will drift whether or not there are fossils. So we can say that fossils will not influence continental drift.
Fossils are not influenced by continental
drift. Yeah, but we can use them to track how continents have moved. It says, let's fast forward 50 million years when California has drifted away from the USA. If there's a plant that grows in California and Nevada, we will only find fossils of this plant in California and Nevada. Right. We can then track it to say that it was by Nevada. For the second answer, just fossils do not influence continental fossils on different continents that were once together. Plants know that continents drifted once apart.
Yeah, that's my favorite way to test it, honestly, because looking at fossils, like, as a kid was always, like, the coolest thing.
And it's like, what, that came from that place, too? That's crazy.
Yeah. We're like, this is an egg?
So, I mean, like, we can still use that. It's just that we're not going to be able to track how long it took, but we can track that they were by each other and that something did have to happen or else they're not by each other anymore.
Yeah.
So, yeah. Okay, and then the next one. Let's see, you said it was the ocean drilling?
Yeah, you were talking about that. I want to know how long this has been. I mean, it's probably been like 20 minutes, but yeah. So when are these due every Saturday?
I believe so.
Thanks. I am quite ill. Oh, and I have to work today. It's gonna be fantastic.
So let's see if this one comes up. Science in search of Earth's secrets. Like tectonic work.
Goodness.
Okay. Also, looks like they still are doing it.
Okay, that's what I thought.
Yeah, because this post was in 2009. Okay. With 3 more planned, so they have 3 more planned expeditions. But I'm wondering if.
So they're still doing it. So describe exactly like what it does and how it proves.
Okay. Let's see. No, that's not. So we are trying to get sediment from special time periods of Earth's history. For example, from the switch in Earth's climate state from a greenhouse world to the current icehouse world, which is a more imaginative way of identifying when huge ice sheets first grew near the poles of the planet. So it sounds like with that one, there's some of it that is still just keeps going and it's not all going back in, is what it's sounding like. And so they're trying to figure out what era it was in when that mantle was happening.
Oh, like is it like a new mantle being created? Like not a new mantle, but is like a new rift being created? Or...
Yeah. So like every time that process is happening before it goes down, that's one part.
Yeah.
So there's like.
So they're trying to see how long it was before that one was created.
Yeah. So that they're like the greenhouse, and then what they're seeing, we're currently in an ice house. The ones that they're testing are in the ice house, where. So it's the ones that are near the poles of the planet. So that's got to be hard if you're like out there.
Yeah. So they've been testing the ones near the poles of the planet to check how old they are.
And to see if they were. So I guess we could call them. What can we call them? Because if it's going by the end and recycling, should we just call it an era right now? Just for this purpose. So like there's a greenhouse era, and it's saying that we're now in the ice house.
Okay. Check how old is it a fault or what is it?
So that's, I don't know if you call it a fault, like that's kind of
Is it a ridge? Is it how would you describe it?
Well, isn't the ridge the one that's in the ocean, right?
Well, a ridge, yes. Yeah, no, actually that can happen on land too. It's just when two plates move away from each other and then like it bubbles up. But apparently I was reading it, I watched like in the online homework. There's this form like a grotto or something like that. So like if it spreads, you'll have like two like ridges on the side looking things, and you'll have like an indent. But in the ocean, it rises up and pushes up, so you'll have like more of a that kind of shape. It's from what I understood.
I don't know exactly where they're testing this at. That's the thing. Because they're going through it, they're trying to do different spots.
And they're just checking how old does it say exactly like what they're checking, like how old the what is? I could just plug and plug. I have it on the phone.
Okay, so we're trying to get these specific time periods of Earth's history for the last 53 million years. And for us to be successful and achieve our aims, we need to plan where exactly on the planet we need to take our temporary home. The Geology resolution, that's that big ship.
We could just call them the divergent plate boundaries. All the divergent plate boundaries, Father. I mean, because they're divergent and they're boundaries on the seafloor that are spreading.
Yeah. So it just sounds like they're just trying to hit any point they can in the ocean to see if they can find anything. Yeah, that's 53 million years old. Because like there's some big slabs in the ocean that aren't like recycled yet, I want to say, because you know how it keeps pushing.
Yeah.
And so they can test that middle part is what I'm thinking that they're trying to do.
Like some of them, they're probably like trying to see how fast it's growing or but I know that like it's just that the oldest, like some points don't even make it to 180 years old before they refresh. But like it showed like the way, because we were on the first lab, you go on Google Earth and then you can kind of see like it shows the colors like from like youngest to oldest, and you can see that like where it just refreshes and like it hits 180 and it just goes.
Yeah.
But
so I guess with trying to do an experiment like that is we could try to have everyone on one different continent.
Yeah.
Or not continent.
On like a plate.
One different plate, yeah. And then when they would drill it, and then they bring back what they have from those places and see if they can compare it and just see how that's going with those plates now. But
yeah.
I just think that'd be kind of cool to see if
like you just drill and compare the different areas.
Yeah. Okay. And then the other one we were thinking of, the GPS.
GPS tracking.
Because I almost want to say if we get a GPS with a sensor, that way it goes off and not only tracks everything, but we're seeing the movement of it too.
Right.
So that way we not only are notified when it's moving, but also the depth of how it's moving.
Yeah.
And like I don't know how well that's gonna work in the ocean though, with seeing the depth of it.
Yeah, well, they do vary. They go, well, kind of, just barely, because mostly it changes around the plates is usually where it goes, like, because when they're pushing together, it sure causes a trench.
Yeah. But I'm saying, like, I want it to, like, even track, like, the slightest, like, a little, like, 1 millimeter or whatever kind of thing. So, like, even though it might be super gradual that it's moving, but we're tracking every little thing so that in the space of, I don't think we can do 1,000,000 years. If we did,
well, it'd be a long going experiment.
Yeah, if we at least would test it for 100 years and see how long it's taking for one little part to move, and then we can predict if it's going to stay, if it's going to try to go faster. It just depends on if the movement jumps a lot or not.
Yeah. So like, this would be like an ongoing experiment. Like you pass on every time you die. I don't know why they don't do that. I feel like that'd be like the most.
Well, I wonder if they do, but I just can't find it.
I don't think they do. Scientists like to take their own credit.
That's true.
Like, I can't imagine. Unless it's like a family of scientists who just like die and they keep going.
I don't know if they have a museum about plate tectonics, but I think it'd be fun to have a museum of plate tectonics like around San Andreas Fault, kind of near that, so when people would come visit that to see the fault, they could go to a museum.
I feel like they probably do.
I would think so, but I just have no idea if they have a museum or not, because I don't go anywhere except to Idaho. So.
Yeah. Well, in Oregon, we have like museums on, like, so we have like you have an aquarium, and then the aquarium will span over like talk about like the volcanic activity under the sea and like all like how the continent's moving. It's just random. It's so weird. Like I want to hear about the sea. Why are you telling me about this?
Like I want to be able so people like come like sit in like one part of it, and then while they're sitting there, they can see how like the Earth's like everything. And then so clicking on one of the GPS spotlight stuff, it says that the Earth kind of moves like a Ferris wheel, and rotating it counterclockwise with angular speed. So I guess I'm still trying to figure out what that exactly means. Like I get that it's like spinning around, that's kind of how it's moving, but I'm kind of stumped on that. So I think it'd be cool to get more into that and kind of have like a visual for people to come in and see.
Yeah, so people actually kind of have like a better idea of how things work. Because like I got in this class and I was just like, what is this word? Or like, yeah, I understand that. Because yeah, it would be nice for us to kind of have a better idea of, because it shows us actually like videos of how things move instead of us having to try and explain it with our words. And that would be a lot more helpful.
I also wonder if they're talking about the Ferris wheel and the light that sometimes it feels like when you're at the top it goes slow, and then when you go like when it gets to that point where it's hitting, that's probably where it goes faster. Or I don't know. It just shows a picture and it just talks about like velocity and speed. And
well, maybe that's like how the plate works. Like so, like the plate, it feels like it's going slow as it comes up.
Then when it finally contacts,
it just like, but like, it couldn't move at like a different. I kind of want to just show you. Like, let me pull it up. Google Earth.
Yeah, but with that, because if we had this,
well, I think
GPS, we could have it in the museums, and then they could see the whole thing happening.
Right.
In every single museum. If I'm thinking if that's possible, like, oh wait, but we have the budget and time. So
yeah, that's possible. We can do whatever we want.
I'm like, okay, what do we got? So I mean, that'd be cool because then you could have that, and then you could have like little demos, like the kids do it in the museum to show it, and then I don't know, just
something that kind of like fun and interactive.
Yeah. Okay, but you're talking about Google Earth.
Yeah, I'm pulling it up right now. It's like start Google Earth again. I mean, because like there's a an add-on that the teacher gives you, and it shows you how old like the ocean is from and where it's moving at this time. It's really cool. All right. Okay, mine's loading.
I got mine up.
Do you have the attachments already added, like the?
Oh no, it's just the regular Google Earth, so I probably don't have that then.
Yeah, so the teacher gives you like So let me show you. You'll get this. It's in like the folder.
For the first week.
Yeah. I'm trying to find what I'm looking for. C4H, there it is. Okay, so like look at. So this is the one I was talking about. This is between like America and Africa, and so this is where it's like getting older and just pushing under, and then this is where it's brand new, and so.
Yeah, that'd be nice, because I was just looking at Google Earth and I'm like, well, I can see some of the ridges and some of that stuff, and I'm like, I don't see the movement.
So like this is let me see if I can do. There's like a tool I can use to show you. Yeah, that's what I have. Okay, so like as you. Oh my gosh. No, I want my other path. Where is it? Showing. Add path. You're not even a path? Believe you. Path. Okay. And then we want to map to C4. Oh wait, I'm not supposed to close it. Okay.
I haven't done this yet. So.
Okay, so C4. And then you'll go to altitude and you'll clamp it to the C4. And then you just go. Okay, what are you doing? Come on. Why is this being weird?
So will it go all the way down and you can see the ridges going up and
like,
down?
Yeah, it's supposed to like let you draw. It's annoying. Okay, there we go. And then we want to clamp it to the C4. View. So path. It'll show you like the ridge. Okay, so we want path. View. Show elevation profile. And this is what it's going on. So this is the ridge. So like see how this is like the middle and this is where it's going up.
Yeah.
And then it's like going down on each side. So that's the ridge. And so this is the new land being formed, and then this is the older things. So they'll have you do something like this in the lab, but this kind of just shows like look how much faster this one is moving.
Oh, wow.
It's like it's comparing. So the thicker the color, the faster it's moving, because it's spreading. Because this is 10 million years right here, 0 to 10 million years, and then it's just moving. So
like these ones right here.
Yeah, this is.
So like, I'm wondering with the ocean drilling, they could probably go over here and test those spots then.
Yeah.
Like they're the ones that are.
Yeah, like honestly, this is probably the most interesting spot to test,
Yeah.
because it's an interesting spot because it's.
There's nothing going on. It looks like it's almost just standing there.
That's not standing there. Well, it's like slow, but it's like it's a weird push. It's like pushing from all these different sides.
Well, so if it's pushing, do you think that that's soon going to become a continent coming up if it's pushing like that? Because nothing's happening to it. That's still 180 years.
Let's draw path and see what's going on here.
Because like, you know how we always get those little islands around Hawaii and all that stuff always popping up? I'm wondering if that's slowly happening here to where it's going to be.
No, it's very flat. It's just older. It's just not. Oh, never mind. It is not very flat. That is interesting. I don't think it'll be a new continent, but it might cause some islands and things like that. But and I think there are little islands out here.
Oh, okay.
Yeah. So
it is doing it. It's just slowly popping up more little islands.
Yeah, and then this is a trench.
Oh, okay.
It's like this is super, super deep. Negative. Wow.
So it seems like what we're thinking about, they already have a lot of stuff, but we can just kind of play around with it.
Well, yeah, we're just supposed to do things that are supposed to prove that plate tectonics is existing, and this is one way to prove it. So I mean, it's not like it's just because someone else is doing it doesn't mean we don't need to do it. We're here to prove that what they're doing is true.
So I think it'd be smart to do like bunch of like how there's like national museums, how we do like plate tectonics museums, so people can go and like understand that. Because honestly, the only time I've ever really learned about plate tectonics was the little science classes.
Yeah.
And so this is probably going to go more in depth than I have before with plate tectonics.
Yeah.
Because like I just have this view, and I see that kind of the trench and those drips and stuff. So I'm like, that's cool, but I'm like, I don't get what's happening at the same time.
Yeah, I know. Like the add-on that the teacher gives you, you kind of just like drag and drop it into Google Earth, and it shows you a lot more. It shows you like where the volcanoes are, and it shows you where the plates start and end, and so it makes it a lot easier to kind of see
and understand how the plates are moving.
Yeah, and understand kind of how you would test to prove the like plate tectonics. Okay, I'm wondering how long this video is going. Because I am starting to feel really ill. Okay.
Mine just keeps saying try again. I don't know if it's actually recording me or not, but that's okay.
Well, your voice will be in here, and I'm giving you a 3 because you've been doing work. So. Ugh. So, what else can we go over? Or is that pretty much it?
Any lasting thoughts you can think of about plate tectonics?
Well, like honestly, it makes sense to me that someone says like, oh, like look at the age of these rocks. Like as you progress, they get much older. Like these are only like 1 million years old, and then this is 2 million. This is like 10 million. This is 20 million. So like as you can see, what would cause these rocks to be younger in the middle and older as they go out? It has to be some kind of force pushing it out. And just like what you said with the GPS, if someone's GPS testing these and showing that like they're actually making
even the
slightest movement in that direction after you've already said that this is the direction that they're moving, that would be huge. And then even testing like fossils, like it makes sense. You don't have tigers in the Americas. Like you don't find tiger fossils in the Americas. So it's just like finding a mesosaur fossil in the like.
Yeah, I get what you're saying. I
can't speak. My brain is just like I'm digging it. Okay, but so I feel like these are enough to really test kind of the theory of plate tectonics, because it definitely shows that like Pangea was a thing. Like these were connected at one point, and so.
And then tectonics happened.
And they moved. And we have different plates, and we have different countries, and we have plates in the oceans that are pushing things together, and maybe in like the next like 180 billion years, another country will move together.
Very true.
So I am gonna call this a good. We shall end this.